Hello everyone. How are you guys doing? Welcome to one more session in machine learning, and this is session 5. And today we are going to talk about more about, building models using machine learning.
So, machine learning is one of the most buzzwords of this century. Not only organization, but people or resources are looking forward to learn what is machine learning because it's hugely in demand. Before we get started, let us have a quick round of introductions about myself. I am Krish and I am having an experience of 10 plus years in the ML field on machine learning and deep learning projects, and I've worked with different domains. So I have opened up Anaconda and now I will be launching Jupyter to walk you through the codes and like what all pre-processing and what all the steps. I have spoken earlier about the modeling steps that are involved in data modeling, and now today I'll going to show you how the modeling is done. Okay, so when I talk about data modeling, so there are two kinds of solutions that is available. One is like when you are predicting numbers. The other is when you are dealing with, strings or classification. So this kind of problem is known as classification or a classification problem, and when we are dealing with numbers we are doing a regression problem. So there are two kinds of problem statements we solve using data modeling. One is when we are doing with numbers, we are predicting anything like what's the price of the house, what's the salary is going to be, what's the GDP is going to be, what the population is going to be, or like how many victims is going to be. Okay, so this is something which we do with numbers, and when we are doing with that we call a regression problem. But when we talk about a classification problem, we know like whether this person will survive given this type of what's the propensity of these what is the propensity of these patient being surviving given this dose is given for a pharmaceutical industry. Or for example, I want to find out, okay, what's the chance of this customer will churn from or won't return in my website or in a retail store or somewhere else. Okay, or like for example, what is the chance or what is the chance of survival, or what is my chances that these loan will be a default or not. So whenever we are doing anything, whether yes it has to do yes, no, maybe, might not, so we deal with a classification problem. So these are two type of problem we deal with using machine learning. So this is the Jupyter notebook, or this is the problem statement which we are going to talk about. But in case if you do not have Anaconda installed, there is also one option which is available to you. So let me just tell you, which is about Google Colab. Google always gives you an interface. It gives you a Jupyter environment where you can take up, when you can write your programs. Okay, let me just show you. Just type in Google Colab and it will just open up. Okay, type in new notebook and your Jupyter notebook is opened. So it's pretty much simple. So this is one of the Jupyter notebook where you have got GPU enabled system, or you can also have TPU enabled system, which you do not get. Like for example, I want to run a program where I need very high-end deep learning type of problems. I can run in Jupyter notebook. There also you have a file system which stores your file. You can rename the file. You can execute line by line. So that is pretty much simple. Only thing you have to keep in mind, like this is like once you close this session, your session will get closed and you have to again start from the beginning. And you also to keep in mind, like the libraries are just temporary installs which happens. So if like I'm working with a couple of libraries like Seaborn library, Pandas, NumPy, so some of the libraries will be pre-installed and some it will require installing. So okay, first time if I opened a notebook and I am working on this, so I have to install these libraries, and once I close it again, the next time I log into the system or log into the Google Colab, so again I have to install those libraries. So as of now you won't be requiring Google Colab, but you must know using this Google Colab which Google offers to you completely free. It is a GPU enabled server which is available to you, where you can do any kind of deep learning type of problem solutions. So as I have spoken to you earlier, so when we get any type of data, there are a couple of steps that you should do. So when you have any kind of problem statement, so what you have to do first is import. Step 1 is import the data into the Python environment. Next thing comes is about when you find out what data it contains, where is your pre-processing. It plays a very important role. And the third part that you are going to do is about doing the EDA, exploratory data analysis, where you find out different insights. Okay, the fourth step that you perform here is your train and test split. Fifth is your training the data, and the next step is testing the data, testing your model with the test data, and the final step is your evaluation or validation, so to check how good is your model performing. So first you have to import the data into the Python environment. So if you are dealing with one file, it becomes very simple. So if you are working with 10 different files, it makes sense like you join the file and make it a one flat file and then import it to the Python environment. If you do not have that much time, or you do not have a good knowledge of SQL, though, one more thing which you can do, you can import all those files into the Python environment, okay, and then do the joins in the Python environment. Next thing that comes is all about pre-processing. In pre-processing, it's all about if you have got any outlier, okay, or if you have got any missing values. So all these treatments are done. Or if your data is of different scale, standardization or normalization is performed. So pre-processing is all about making it analysis ready or model ready. And you'll find like most of the time you will be spent finding in doing the pre-processing and the cleaning stuff. Next comes your EDA. EDA is more or less like finding out what insights your data is seeing, or what all insights you can find from the data, what all relationship the variables are having with different variables or with the dependent variables. Here also you have to identify which is your dependent and independent variable, okay, and the relationship between them, and you have to identify those independent variables which are of highly related or have high influence on the dependent variable. Next is based on the data that you are having. You have to split it into train and test, where you are going to train the data, then in the next step using your train data set, and finally you test it out. Once the testing is done, the final thing you have to validate the data. That is, you have to find out how good your model is performing, okay. And once you're satisfied with the validation, you deploy the model. And in case if your validation is not up to the mark, you go back to the train set, then do the testing, may change some parameters and do the testing, and again validate it, and your model is, once you are happy with the results, and your model is ready. So what I'm doing here, I am calling some of the libraries which I'll be requiring in my model. So Pandas is for data frame. NumPy is for one of the libraries which is used for numerical calculations. Okay, Pandas Profiling. This is one of the interesting libraries which I use mostly, because this is one of the library which is a complete EDA type of analysis or EDA type of summary which is going to give you, and it is very important for your data set. If you do a Pandas profiling, you'll find it's you'll get lots of insights from your data, which otherwise you have to spend a lot of time finding different insights. But if you do Pandas profiling, you run it, you will find the correlationship, how your data is spread, how the variables are distributed, everything you are going to get it at one place. So that is one of the most important and critical libraries. So I'm using stats model library, math library. For sklearn I'm using pre-processing. Seaborn is for the graphical representation. I'm using matplotlib as well, and I'm using train test split. So I'm just importing this library. So these libraries are already installed in my system. In case if you find any issues where it says like this library is not available, so you have to just do pip install and the library name, and you have to just install the library based on the three ways which I talked to you about earlier. Like you can install that library using here by just placing the exclamation mark and pip install and the library name, or you can have your command prompt do that installation for you. Always prefer to use command prompt for the installation. Okay, next what I am done is I am just importing this data in my Python environment. So next I am finding what's the shape of the data using the command. Okay, data, this is the data name, a data frame name which I have given, and the shape. It will give you, okay, I have my data contains 149 rows and 21 columns. Now I want to find out, okay, what is the top two columns is looking, top two records is looking like. So what I do, I name the data frame dot head and I do 2. If you want 5, you can write it 5. So this is how your data is looking like. It will give you the top two the topmost two records from your data frame. If you want to find out the bottom two, so you can just type it the data frame name dot tail and 2. It will give you or 2 or 5, whichever you feel like you want to see the data. Okay, next I want to find out what are my column names. So what I do, I take the data frame name dot columns, and these are the column names which is available to you. Now if I had to find out what is my descriptive statistics from this data, so what I do the data frame name and I do describe, and it's going to give you my count, mean, standard deviation, minimum, and the percentiles, min, max, and the percentile of your entire data. And remember, this is going to give you only those variables which are numeric in nature. You might find like some of the fields which are when you have imported the data, it has imported it as a numerical field which ought to be categorical in nature, or a string should have been. Like for example, like ratings is always, as you know, you cannot do any calculations with the ratings, but prefer to use it as instead of a numeric, to change that format into a string and then use it in your model. So if you say, so similarly there are some, it depends on case study to case study whether you want to use these variables as a numeric or a string. Okay, so what I'm doing next is I'm finding out what is the data type of these variables. So I've put in the data frame name and the data, I've put in D types, and it will give me show me what are my variables and what all data type they have been inputted into, or in as which format they are into this system. You can see like TPI success factor, and most of my variables are int, but here this TPI success factor is imported as a float. So to be on the safe side, or to be have a same pattern, so what I do, I just convert it from float to int. So what I do, how do I do that? I select the data frame name and then I select the column name. So how do I select the column name? You can in between the box bracket you put the quotes and the column name, and equals to, again the same thing, dot s type and the data type you want to convert it into. Okay, and it will be done. Next is if you want to find out whether your data contains any null values or not. So how do you are going to do that? Data frame name is null. Okay, that's the function you are going to use, and you have to find out how many records are there. For that you just put the sum, and it will give back to you how many null values, if there are any in your data set or not, it's going to return. Since you are getting zeros, that means there are no null values in your data set. Now you have to find out the descriptive statistics. So for that I will be importing the pandas library, and I will run this command, pandas profiling report, which I'll be executing. Based on that, it is going to give me the pandas profiling report. So for first thing you have to do is you have to import these libraries, and if it is not installed, you have to install these library. Okay, let me show you how your the Pandas profiling report looks like. Okay, so this is the Pandas profiling report. It give you a general general summary of how your data set is looking like. Okay, so this is the overview: number of variables, number of missing cells, duplicate rows, and all these things. Now let's talk about, now this is the first thing. Then if there are any uniques or any warnings or not, since id is one of the variable which is unique, so it has given us as a warning because you cannot use it. It is an identifier which is used, so that's why it is completely unique. So now when I talk about the variables, it is for each of the variables it's going to give me distinct, unique, missing, and their distribution. So this is for id, date, so technology, business, incubator, performance. So all these different variables it's going to show me. So this is quite interesting. Next is it's going to show me is the interaction between different variables. So it's going to show me the correlation between the numeric variables. And yes, please remember this is for only numeric variables like rating of this institute and knowledge donation. So how it is distributed, it is showing me. Or like for example, technology, business, incubator, and I'm finding out rating of the institute. So this is how it is looking like. Or say knowledge collection. So this is how the the distribution is of the different variables. Now for it has also the correlation, cross correlation it is showing me. So that is for a customizable cross correlation which can talk about, but this is the cross correlation for all of the variables it will be showing. It is color coding. The greener, the bluish, more the bluish, the higher the correlation is, and the more the red, the higher negative correlated the variables are. Okay, so which now let's talk about the missing values. It will give me how many missing values are there, and it has also different matrix which is going to show me based on the different variables. And the last thing which is going to show you, it's going to show you the first 10 and the last 10 rows. So that's which is again I told you it is about a Pandas profiling report which it creates, and it becomes very helpful for you when you are dealing with these when you want to find out about this data set. Like for example, you're working with one of the data set for which you have got no idea about these variables, about this data set. So this one this library is going to help you immensely. So what I've done is I found out the cross correlation which I've found out here. It is already available in this Pandas profiling report, but for a better explanation I have found out here as well. Okay, now what I'll be doing is I am finding out whether my data contains any outliers or not. As I have explained to you earlier, for finding out your variable contains any outliers or not, the best possible way to represent it graphically is using a box plot. So if you see, this is the LCL, the lower control limit, and this is the UCL. So this is actually the LCL and this is the UCL. So these are the whiskers. So these are some of the extent to which your data can spread. If you look at this box plot, so this is for one of the variables like TBI, success factors. This is for knowledge donation. You can see that these are the values, these are the dots which are standing apart compared to where this your graph is lying. So this is the LCL, UCL, and this is the median, and these are the whiskers which is there, but still there are a couple of points which are falling beyond. So we can say based on from case study to case study whether to classify them as outliers or we can just consider it, or any capping is required. It's completely depends on the data scientists how they are interpreting it. Okay, now next is we have to drop a couple of variables which are of no use. So like for example, ID, which is completely unique, and date, which if you use it in your data it becomes very difficult to go ahead with or you work with. Now we have to find out we are creating dummy variables, like as I've told you, like if you have got any categorical variable, so what you have to do, you have to create dummy variables. Like for example, if you have classes of say 3 classes, yes, no, maybe. So what you'll do, you will create three dummy classes, yes, no, and maybe, with 1 and 0 with binary coding. If it is yes is present, the column with yes will have 1 and the rest will 0. Similarly, if it is maybe, so maybe will contain 1 and the rest will be 0. Okay, so that's what I am doing. I am creating dummy variables. So what I'm doing is, here is I am creating a dummy variable, then I am combining the dummy variable into my dataset and removing the original dataset, because it gives me flexibility to find out correlation as well with the, since it is, a dummy variable, so I will have a categorical variable converted into a dummy variable. So the next thing what I can do is, I'm doing a since my data spread is across my data, if you look at the data, my data is spread across different scales, so it makes sense if I do, so if it is 1, 2 and it is 100, it makes sense if I do a min-max scaling in my data set. It becomes so that my data will range from 0 to 1, and it becomes easy for me to work with and do the analysis. So what I'm doing here, why, is I'm defining my independent and dependent variables here. Okay, the x contains my all the independent variables and y is my dependent variable. So TBI success factor is my dependent variable which I will be predicting, and x contains all of the independent variables. Next, what I am doing is the train test split, which I am doing in like the test set is of 70-30 ratio. I am doing the train test split, like 70% of my data will be a training data set and 30% will be a test data set. So this, if I look at the shape, like 104 records will be my training data set and 45 will be my test data set, which I'll be using to test it out. We have to find out which of the variables are of importance to you, or which of the variable is of importance, or like for example it is like feature selection you have to do. So you have to select those variables for your modeling which are influential to your dependent variable. So for that we will be using recursive feature elimination, which is RFE. What does this algorithm or this method do? It will give me like which of the variable is important to me. Okay, so based on running RFE, I get, like, if it is true, that means it is of importance. If it is false, that means it is of not important in my model. Now what I'm going to do, I'm doing a regression analysis or linear regression model, which I will be plotting in my model. So I'll be calling OLS, ordinary least square method, for plotting, or calling this library for building my regression model. So this is the code for getting my building the model or training the model. Okay, so if you look at these, so these are the different statistics which you are going to get. That is here, when you are building a model, the focus should be on your R square. R square is it will say is how good your model is explaining the original, based on the original data set or the actual data set. Like you can say it is 96% it is explaining. So if the higher the R square value, the better your model is. Okay, and also you have to keep in mind your p value should be less than a 5% level of significance. Okay, so this is the first cut which I have just plotted in my data set. Next, what I have to do, I have to find out VIF values, which is the variance inflation factor. It is all about multicollinearity. So when you are building, when you're working on a regression, you have to, or in a data modeling, you have to make sure like the independent variables are not related to each other. If they are related to each other, your model will become biased and it will be very difficult to make prediction. So that's why you have to remove those variables. Like for example, two variables are highly correlated with each other, so you can drop one of the variables which are of least influence or significance on the dependent variable, and you have to model it with the other variable. So if you use at VIF, you can see this variable knowledge collection is VIF is coming to be high, so I have to make sure I drop this variable and use it in my data set. So I have after dropping these a couple of variables, I find my VIF is less than 4, and I can go ahead with building my model. So this is the final model which I'm getting. If you look at the p-value, my most of the p-values are less than 5% level of significance, and my r-square value is coming to be 96%, which is really cool, which is really the best model I can which I can get. Now the next thing is we have to make the prediction on the test data set, and I have the RMSE scores. The lower the RMSE, the better your model is. So that's all. So once you have made the prediction, you have to test how your actual and your predicted are, how spread they are. So the lower the RMSE, the better your model is. Here you can have a better RMSE scores in your model, which you can have a better solution. So RMSE will give you how your model is, like how your predicted value is different compared to your actual value, or how your predicted value differs compared to your actual value. Okay, so based on the prediction, you have your final model ready, and you have predicted the final values. So that's all about modeling using machine learning. So here so what are the steps? Let me just recap of the things that we have learned in this step. We first import the table in your Python environment. Next is we check the do some EDA, find out how many outliers are there, how many missing values are there, or how the variables are related to each other. So that's all about EDA. Now next we find out if there are any outliers or not. If there are, I cap them or remove them. If there are any missing value, I impute those values. Okay, next is I have my data is pre-processed or it is cleaned. The next step which I am going to do is I am going to move to the next steps, do the train test split based on different ratio. You can do that. Next is I have to separate the independent and the dependent variable. Next is I find out what the relationship the independent variables are having with each other, so that I choose those independent variables which are less correlated within themselves but highly correlated with the dependent variable. And once I'm happy with that, I move to the next step where I train the model. When I train the model, I have to make sure my r-square is high and my p-value is less than 5%. So once that is done, I test the model, and my model is ready. So that's all from this session. And don't forget to like and subscribe to my channel, and you can press the bell icon so that you keep yourself updated with the upcoming videos that are coming in. Thank you for watching. Have a wonderful day. Thank you. Bye bye.